Within Azure Virtual Machines, disks are essential storage units for both operating system and data. They handle persistent data even when the VM is deallocated. OS disks are automatically created during VM deployment, whereas data disks are optional and can be added to hold application files or logs. Azure offers both managed and unmanaged disks, with managed disks simplifying deployments through automatic management of storage accounts. Understanding disk types, performance tiers, and capacity limits is crucial for production environments. By choosing the appropriate configuration, administrators can ensure reliable hosting, optimal performance, and simplified scaling aligned with organizational needs or workflows. Azure Managed Disks automatically handle the underlying storage account for each virtual machine, achieving high availability and simplifying disk provisioning. Administrators do not worry about limitations related to storage accounts, such as maximum IOPS or capacity constraints. Unmanaged disks rely on manually created storage accounts, requiring careful planning to avoid performance bottlenecks or resource contention. In larger deployments, managed disks typically offer better scalability and reliability. However, some legacy implementations may still rely on unmanaged disks. Transitioning from unmanaged to managed can be done through migration processes, ensuring minimal disruption while enhancing operational efficiency and simplifying administrative tasks for teams. Azure provides several disk technologies, each tailored for specific workloads. Premium SSD disks offer low latency and high performance for production databases, mission-critical applications, and latency-sensitive systems. Standard SSD disks balance cost and performance for general-purpose workloads. Standard HDD disks are designed for less critical applications with lower IOPS requirements. Selecting the appropriate disk technology depends on usage patterns and growth expectations. Maintenance tasks, such as OS patches or data backups, can also influence disk choices. To optimize expenses and performance, administrators often differentiate storage tiers across virtual machines, ensuring each disk type aligns with its associated workload effectively ongoing. Azure performance tiers dictate the throughput and input-output operations per second achievable by each disk type. Premium SSD disks feature multiple performance tiers, allowing administrators to adjust throughput on demand. Standard SSD and HDD options also have defined performance bounds, but at lower capacity and speed. Each tier has an associated set of service-level agreements that assure minimum performance metrics. When scaling or handling peak loads, the ability to move between tiers becomes beneficial. By monitoring disk utilization and application demands, administrators can select the most suitable performance tier, balancing cost-effectiveness with a desired level of operational throughput, long-term reliability. In Azure Virtual Machines, the OS disk holds the operating system files, while data disks store application-specific data, logs, or databases. An Azure VM must have exactly one OS disk, whereas data disks are optional and can range from 0 to many, depending on VM size limits. Temporary disks, often ephemeral, provide non-persistent local storage for page files or caches. This temporary space is lost upon deallocation or hardware reallocation. Administrators assign disk roles based on workload requirements. OS disks typically require robust performance and reliability, while data disks can vary in tier depending on performance demands and budget constraints. Attaching data disks to an existing Azure VM involves selecting the VM resource in the Azure portal or using CLI commands to add new or existing disks. For a portal-based attachment, navigate to the VM's disk blade and specify the desired disk size, type, and encryption settings. Use Azure CLI or PowerShell for scripting or automating disk attachment across multiple VMs. After attaching, initialize and format the disk within the operating system to ensure readiness. Storing application data separately on data disks can improve organizational clarity, enhance performance by isolating workloads, and allow for more flexible management of storage capacity requirements. When provisioning Azure disks through templates or bicep files, administrators can specify properties such as size, SKU, and location. These infrastructures as code approaches streamline deployments by enforcing consistent naming conventions, capacity settings, and performance tiers across environments. ARM templates reference resources using a standardized schema, while Bicep provides a more succinct syntax. Within these files, each disk resource can be linked to a VM or kept independent for later attachment. This method integrates well with CI/CD pipelines, reducing manual effort and ensuring repeatable, reliable disk deployments. Proper provisioning fosters efficient performance and reduces risk from inconsistent or ad hoc processes overall. Azure Disk Encryption uses BitLocker for Windows or dmcrypt for Linux to protect data at rest, ensuring compliance with regulatory and organizational standards. It integrates with Azure Key Vault, which manages encryption keys and secrets. Administrators can specify customer-managed keys for greater control or rely on Microsoft-managed keys for simpler configuration. The encryption process typically requires a VM reboot and reconfiguration, but can be automated for larger environments. Encryption ensures unauthorized parties cannot read disk data, even if they gain physical access. Proper management of keys, along with regular backups of the vault, enhances data security and operational continuity significantly. Backup strategies help protect against accidental deletions, corruption, or hardware failures. Azure Backup can capture entire VM states, including all associated managed disks. This service uses recovery points that can be restored to the same or a different region. Alternatively, custom scripts or third-party solutions can snapshot and copy data disks to alternative storage. Administrators should schedule backups based on workload criticality, ensuring frequent restore points for essential applications. Testing restoration procedures builds confidence in data recovery scenarios. Coupled with disk encryption, backups ensure that even if security is compromised, an intact, secure copy of system data is available rapidly. Snapshots are point-in-time copies of disks, providing fast backups or a foundation for new images. They can be incremental, tracking only changes since the last snapshot, reducing storage costs. Administrators create snapshots through the portal, CLI, or templates, specifying the source disk and a target name. Once created, snapshots can be used to restore a disk or create new managed disks for dev/test environments. For consistent states, consider quiescing or shutting down the VM before taking snapshots. Carefully retained snapshots enable quick rollbacks after updates, but storing numerous snapshots can increase resource consumption without proper lifecycle management careful and oversight. When large data volumes need migration, the Azure Import-Export service supports transferring disk data via physical hard drives shipped to Azure data centers, bypassing network constraints. Alternatively, online data transfer can be achieved through Azure Data Box or direct copy over secure connections. Evaluating network bandwidth, costs, and timelines helps administrators select suitable data movement options. When performing data imports, disks must be prepared in the proper format, i.e., VHD, ensuring compatibility with Azure resources. During export, administrators can retrieve disk data in a portable form for offline processing or integration with on-premises or alternate cloud environments efficiently and safely. Scaling VM disks to meet growing demands often involves upgrading from standard HDD to standard SSD or premium SSD. Administrators can also increase disk size to enhance capacity or throughput. By carefully assessing metrics such as disk utilization, queue length, and application performance, teams can determine when scaling is needed. Upgrades may require short downtime or careful scheduling to minimize disruptions. Azure's flexible nature lets administrators combine multiple disks within a VM, employing tools like storage spaces for enhanced throughput. Sustained monitoring and predictive growth analysis are key to preventing bottlenecks and ensuring stable performance for critical workloads' long-term needs. The Azure portal offers a graphical interface for managing VM disks, allowing administrators to monitor disk performance, modify sizes, and adjust encryption settings. Charts display real-time metrics like IOPS, throughput, and latency, aiding in capacity planning. Administrators can also detach or delete disks directly in the portal. Helpful tooltips and Wizard's Guide less experienced users through disk setup processes. Combining portal operations with other deployment methods fosters a flexible, hybrid approach to resource management. However, large-scale changes or complex infrastructures may benefit from scripts, templates, or pipelines, ensuring consistency. The portal remains invaluable for quick tasks and visual oversight daily. Using Azure CLI, administrators can perform disk-related tasks in a scripted, repeatable manner. Commands such as AZ-disk-create let you define name, size, resource group, and SKU. Once created, AZ-VM-disk-attach associates the disk with a virtual machine. The CLI facilitates automated workflows through shell scripts or CI/CD pipelines, enabling consistent provisioning across multiple environments. Administrators can also scale disk size, create snapshots, or manage disk encryption settings via command line arguments. The CLI's JSON output allows easy parsing of resource details for integration with other tools. This method fosters robust, version-controlled procedures for disk management enterprise-wide adoption. Azure PowerShell is another automation mechanism for managing disks, relying on cmdlets such as new AZ-disk, add AZM data disk, or set as a disk. Scripts combine these cmdlets to define disk specifications, attach them to VMs, and configure attributes like caching modes or encryption settings. PowerShell integrates smoothly within Windows-based environments and can also run on cross-platform systems through PowerShell Core. It supports error handling via try/catch blocks, enabling graceful handling of failures. By saving script modules in shared repositories, teams can standardize disk management processes. Azure PowerShell's flexibility and detailed cmdlet documentation facilitate advanced scenarios, including integration with automation accounts or hybrid runbooks and consistency. ARM templates adopt a JSON schema, defining resources like disks, virtual machines, and networks. Each disk resource includes an API version, type, name, and properties block. Properties specify creation parameters such as disk size, SKU, and encryption. Administrators reference these disk definitions when linking them to specific VM entries. Variables and parameters allow dynamic sizing or naming, enabling reuse across multiple environments. Outputs can return disk information for subsequent deployment steps. By maintaining ARM templates in source control, teams ensure versioning and reliable rollbacks. This approach standardizes disk provisioning, reduces human error, and promotes consistent resource configurations in Azure seamlessly overall. Disk costs depend on storage type, premium, standard SSD, or HDD, disk size, and performance tier. Managed disks have fixed monthly rates based on provision capacity, regardless of actual usage. Snapshots and backups incur additional charges, particularly for incremental storage. Data egress for exports also contributes to billing. Administrators should track consumption via the cost analysis blade in Azure or third-party monitoring tools. Right-sizing disks and selecting appropriate performance tiers can significantly reduce monthly bills. Automated scripts that resize or deallocate and use disks help reclaim savings. Proper forecasting ensures budgets accommodate scaling demands without unexpected cost overruns and billing spikes. Beyond encryption, administrators should restrict network access and enforce least privilege principles to secure VM disks. Role-based access control, RBAC, defines who can create, read, or delete disks. Regular review of audit logs in Azure Monitor or Security Center detects unauthorized disk operations. Ensuring all OS and data disks use encryption keys stored in Key Vault prevents accidental exposure. Additional compliance measures may involve advanced threat protection, scanning disks for malicious content. Use network security groups or firewalls to limit incoming traffic to critical VMs. Encouraging multi-factor authentication for Azure administrators and rotating credentials add further protection for disk resources significantly. Azure Monitor captures metrics like disk read/write operations, queue depth, and throughput. Custom alerts can notify administrators when thresholds are exceeded, highlighting potential performance issues. Log analytics can provide detailed insights into disk usage trends, offering historical data for capacity planning. By analyzing these logs, teams can identify anomalies, investigate bottlenecks, or forecast future requirements. Splunk, Yelk Stack, or other third-party solutions can also ingest Azure Disk Metrics for more comprehensive reporting. Performance data helps guide optimization, ensuring that disk configurations align with real-time workload demands. Regular monitoring and timely alerts foster proactive management of Azure Virtual Machine disks successfully. Disks integrate tightly with other Azure services to form comprehensive solutions. For instance, attaching disks to scale sets ensures dynamic provisioning for auto-scale scenarios. Using managed disks with availability sets or zones helps maintain resilience against data center-level outages. Coupling disk snapshots with Azure DevTest Labs accelerates environment resets. Resource Manager locks can prevent accidental disk deletions, while tagging helps categorize costs and responsibilities. Combining role-based access control with conditional access policies and resource policies enhances security at scale. By leveraging these integrations, organizations can unify management, simplify day-to-day operations, and build a robust, future-ready infrastructure with minimal administrative overhead continuously.